here's example 13 with trig identities. So again, if you want to copy this packet we've been using for these videos, check the video description. There's a link in there. You can click that link and open up this packet, print it out if you'd like. So tangent of theta plus 1, quantity squared, minus secant squared of theta, all divided by tangent of theta, equals 2. Okay? So let's go back to our general process here from an earlier video. Always start on one side, try to make it look like the other side, and usually start with the more complicated side. So I think we can all agree that the left side is a little more complicated than the right hand side. So let's start on the left. Okay, so tangent of theta plus 1, whole thing squared, minus secant squared of theta, all divided by tangent of theta. Okay, so what can we do here? Well, nothing really jumps out at us except maybe so here we have something plus 1 and then quantity squared. So let's maybe expand that. Okay, so we're going to FOIL that out. So if we come off to the side here, so tangent of theta plus 1, quantity squared. So remember, that's just the same thing as tangent of theta plus 1 times tangent of theta plus 1. Okay, so be very, very careful. It's not the same thing as tangent squared of theta plus 1 squared, right? It's not the same thing. Okay, powers don't distribute over parentheses like that. Powers do not distribute like that. This is the same thing as tangent of theta plus 1 times tangent of theta plus 1, so it's really foiling. Okay, so if we FOIL, then the first is tangent squared of theta. Outer is tangent of theta. Inner is also tangent of theta, so plus 2 tangent of theta. And then last is plus 1. Okay, so it's really just like a plus b squared is a squared plus 2ab plus b squared, right? It's really the exact same thing as that, but instead of a and b, we have tangent of theta and 1. Okay, so here's a squared plus 2ab plus b squared, or remember, b is just 1. So anyway, same exact thing going on here. So that's what we have here. Okay. So tangent of theta plus 1 quantity squared, FOIL that out, you're going to get tangent squared of theta plus 2 tangent of theta plus 1. Okay, so that's exactly what we have here. So that's tangent squared of theta plus 2 tangent of theta plus 1. Okay, and then we also have minus secant of theta. Or sorry, secant squared of theta. Okay, that's still there. And then all divided by tangent of theta. Okay, now, what do we see here? So we see, here's a tangent squared, here's a 2 tangent, here's a 1, here's a secant squared. So we see tangent squared and secant squared, so maybe we'll think, okay, well, Pythagorean identities, we know that tangent squared and secant squared are related by this one here. So tangent squared plus 1 equals secant squared. Well, if I look, tangent squared, blah, 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 plus 1, well, hey, that's good. So let me squish those guys together. So tangent squared of theta, and what I mean is, let's rewrite the top. So tangent squared of theta plus 1 plus 2 tangent of theta minus secant squared of theta, all divided by tangent of theta. Okay. So tangent squared of, so all I did was I took the top and I just rewrote these two terms, or rewrote the order. So plus 1 plus 2 tangent of theta, I just took these and I switched them around. So remember, you're just adding two things, it doesn't matter what order you add them in. So anyway, tangent squared of theta plus 1, that is secant squared of theta. Okay, that is secant squared of theta. So that's one of our Pythagorean identities. So that's why I switched these around, because I looked at this and I said, okay, well, here's a tangent squared, here's a 1, here's a secant squared. We think about Pythagorean identities. So what I do is I look at this and say, okay, I know tangent squared of theta plus 1 is secant squared. So here's a tangent squared, here's a plus 1, let me get them together. Okay. So tangent squared of theta plus 1, that is secant squared of theta. And then, so that's tangent squared of theta plus 1, so what's left is the 2 tangent of theta. And then we still have the minus secant squared of theta out here. Okay, so minus secant squared is still there. And all divided by tangent of theta still. Okay, well that's great, because now secant squared, blah, 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 minus secant squared. So cancel, cancel. And we're just left with 2 tangent of theta divided by tangent of theta. Okay. So 2 tan of theta on top, tan of theta on the bottom, tan of theta is cancel, and we're just left with 2, which is what we wanted. Okay, we wanted to end up with 2. Okay, so that's really it for example 13. So again, just to recap real quick, we had this big mess here, and what we did first, we FOILed it out. So remember, you've got to FOIL that. Okay, don't distribute powers. Powers do not distribute over parentheses. Okay, make sure that you just multiply, expand the whole thing out. So that's what we did here. And we could also think, okay, well, if we want to do it a shorter way, a plus b quantity squared is a squared plus 2ab plus b squared. There's no reason that we cannot apply that here, okay, even though it's more complicated as tangent of theta instead of just like x or y or a number or whatever. The same rule still applies. Okay? It's still just foiling, expanding, etc., etc. So first, outer, inner, last gives you this. Okay, so anyway, a couple different ways to think about it, but you'll still end up with tangent squared of theta plus 2 tangent of theta plus 1. So we put that in there, then we said, okay, squared trig functions, and there's that 1 from the Pythagorean identities, so let's see if we can somehow use the Pythagorean identities. Well, hey, tangent squared of theta plus 1 is secant squared of theta. So let me get the plus 1 over here, so I just swap the order of these. So tangent squared of theta plus 1 is secant squared of theta. So that's going to cancel with this minus secant squared of theta, and we're just left with 2 tangent of theta on the top, tangent of theta on the bottom, tangent to cancel, and we're just left with that 2. Okay, so that's example 13. Example 14 coming up in the next video.